Welcome back students in the second part of this series. Here once again I am going to discuss about mechanical energy with potential and kinetic energy, because from this video you can take notes on transformation of energy, the law of conservation of energy and the energy degradation. So let's start. Mechanical energy, which can be said to be as either a potential energy or a kinetic energy or a combination of both. Or in very simple way, you can say the energy possessed by a body due to its state of rest or of motion is called the mechanical energy. Thus, it can be also said as the mechanical energy is the sum of potential energy and kinetic energy. It is the energy associated with the motion and position of an object. Thus, we need to understand the potential and kinetic energy also. So, let's see potential and kinetic energy once again with some numericals.
Energy is the ability to do work. Its unit is joule. The ability of a body to do work due to its motion is called kinetic energy. Thus, kinetic energy of a body with mass m and moving with a velocity v is 1 upon 2 mv square. A moving ball, a flying insect, a falling asteroid, and a moving car possess kinetic energy due to both its motion. The kinetic energy of a body is directly proportional to the mass of the body, the square of the velocity of the body. More the speed of a body, more is its kinetic energy. Similarly, more the mass of a body, more is its kinetic energy. Energy is a scalar quantity. Let us solve one problem. A ball of mass 200 grams is moving with 27 kilometers per hour. Calculate its kinetic energy. Solution. Given mass m is equal to 200 gram, which is equal to 0.2 kg. Velocity v is equal to 27 kilometers per hour, which is equal to 27 multiplied by 1000 upon 3600 meter per second, which is equal to 7.5 meter per second. So, kinetic energy is 1 upon 2 mv square, which is equal to 1 upon 2 multiplied by 0.2 multiplied by 7.5 square. So, kinetic energy is equal to 0.1 multiplied by 56.25, which is equal to 5.625 joules. Question. At what speed a person weighing 60 kg should run to acquire 750 joules of kinetic energy? Solution. Given mass m is equal to 60 kg, kinetic energy K is equal to 750 joules. We know that kinetic energy is 1 upon 2 mv square. So, v square is equal to 2k upon m, which is equal to 2 multiplied by 750 upon 60 equal to 5 meter per second. The ability of a body to do work due to its position or configuration is known as potential energy of the body. It is the energy by virtue of its position. Potential energy of a body depends on gravitational force acting on body and height. Suppose potential energy at reference level is 0. A force having a magnitude equal to gravitational force acting on it is applied and the body moves in opposite direction. If the body moves to a height h, then work W is equal to force multiplied by displacement. But force is equal to mass m multiplied by acceleration due to gravity. So work is equal to m multiplied by g multiplied by h. So potential energy of a body of mass m when raised to a height h above the surface of the earth is m multiplied by g multiplied by h, where g is the acceleration due to gravity. Potential energy is also a scalar quantity. It is of two types. Gravitational potential energy is the energy an object possesses due to its height from the Earth's surface. Elastic potential energy is the energy stored by an object as a result of deformation. A coiled spring, an unopened carbonated drink, water at the top of a waterfall, a Ferris wheel before it starts moving are all examples of potential energy. Question. Calculate the potential energy of an object weighing 6 kilograms when moved to a height of 20 meters. Given acceleration due to gravity is equal to 9.8 meter per second square. Solution. Given mass m is equal to 6 kg, height h is equal to 20 meters. Gravitational acceleration is equal to 9.8 meter per second square. Therefore, potential energy U is equal to mgh equal to 6 into 9.8 into 20 equal to 1176 joules.
The energy utilized by the body to do mechanical work is called mechanical energy. It is in two forms, potential energy and kinetic energy. As you can see over here, the falling rock converts its potential energy to kinetic energy. This is known as the transformation of energy. Energy can be transferred in various forms such as chemical energy to heat energy, etc. But you need to remember that the total amount of energy in the closed system used to be conserved. This is only known as the law of conservation of energy. As you can see, the rock which is falling from a certain height has a potential energy. As it is coming down, its potential energy decreases and kinetic energy increases. But at any point, you will see the sum of the kinetic and potential energy remains constant. In the same way, the elastic potential energy and the kinetic energy of this spring remains constant. Let's see for this pendulum, where when it moves from a base point, then it gains potential energy, and when it is coming towards its base point, it gains kinetic energy. But at any instant, the sum of the kinetic and potential energy of the bob of this pendulum remains constant. This is only known as the conservation of energy, and the sum of the potential and kinetic energy, which is constant, is known as the mechanical energy. Today, we cannot imagine our world without energy. There are various sources of energy available to the mankind. The development of science and the civilization is closely linked to the availability of energy in useful forms. And this was possible because of the transformation of energy. Energy can be transferred or can be converted from one form to another form. This is only known as the transformation of energy. Here you can see some of the examples where energy can be transferred from one form to another. As in an electric bulb, electrical energy converts into light energy and heat energy. In an electromagnet, the electrical energy converts to magnetic energy. In a microphone, the sound energy converts to electrical energy. In a cell or a battery, the chemical energy converts to electrical energy. Whereas in a steam engine, the chemical energy first converts to heat energy and then the heat energy converts to the kinetic energy. With the transformation of energy, we come to know about the law of conservation of energy. According to the law of conservation of energy, we can say energy can neither be created nor be destroyed. It can be only transferred from one form to another. and the sum of the total amount of energy in the whole universe remains constant. Such as, for example, if a ball at a height of 20 meter has a potential energy of 100 joule where the kinetic energy is zero because of no motion, will have a sum of mechanical energy as 100 joule. But as it falls down, you observe that there is a decrease in the potential energy with a gradual increase in the kinetic energy. And when you make the sum of this potential and kinetic energy, you will get the resultant amount of energy as to the previous situation. And when the ball falls down or hits to the ground, at that very point, the kinetic energy is at its maximum level to 100 joule, whereas the potential energy is zero. Again, if we do the sum of the potential energy and kinetic energy at this point, we will observe the sum will be the same what we had started with. Now, let's discuss about energy degradation. In the previous part of this video, I was talking about the transformation of energy. And in that, I had said when the energy been transferred from one form to another form, then the total amount of energy remains constant, which is also been said with the law of conservation of energy. But if there is no loss of the energy, then how we can say that there is a degradation of energy? So do the law of conservation of energy is false? No, it is not like that. When we say the degradation of energy, then we actually mean that some of the useful form of energy been converted into some useless form of energy. But if we take the total sum of the energy in the system, it remains constant. Now, how you need to define this energy degradation? You can say in all energy transformation, some of the useful form of energy gets converted or been diluted in the surrounding due to the external factor. Mostly we observe it as in the form of friction, such as for a machine when we say for an actual condition all machines have efficiency less than 1, which implies that only a fraction of input energy is used for doing useful work and the rest of the input energy got wasted out. Here you have some of the transformation of energy. I would request you all to pause out the video and go through each case and identify which form of energy been converted from one to another.